One of our main methods has been factoring. This document's on Google Classroom. It goes through every single method of factoring that we have in 2 pages. Okay? So the first thing you want to check, is there a greatest common factor? Okay, so if you look at 2x minus 8, you can factor a 2 out, correct? That makes things a lot easier. So try that every time, first time through. Okay? Now, the rest of this sheet is broken up into how many terms does the polynomial have? So a binomial has how many terms? 2. Okay. Today, we are going to study the difference of 2 squares, the sum of 2 squares, the sum of 2 cubes, and the difference of 2 cubes. Okay? So the second one is it a trinomial? That's 3 terms, right? We have quadratics that we can factor, and we have quadratic form, okay? And this is all the different ways that I've shown you to manipulate those, okay? So, yeah, it is. Okay, so I'm just giving you a small summary of it. So this would be factoring a quadratic. You know how to do that. Okay. If a is 1, you know, remember multiply and add. I think you're good at that. This part C here is dealing when this number is not a 1. And that's when I showed you the Punnett square. How to kind of deal with that method. Some of you use the X method. That's okay too. Okay. So those are 3 term groupings, and this includes quadratic form. Okay. And then the fourth, or the last one, is 4 terms. 4 term polynomials. Yesterday we studied factoring by grouping, right? This first one is the only one I'll really hold you to. It's the only one I taught you. Okay. You can use these others, but honestly, we just never see. No. I'm going to hold you accountable for A. Okay. If you're interested, B and C work as well. Okay. We use these B and C when we're studying things like circles, which we'll get to, but we just don't use it very much. So, and then at the bottom, here's a little diagram for you. Okay, greatest common factor first, and then you can pick if it's a binomial, trinomial, or 4-term polynomial, and these are the different methods for each. Okay, it's a lot more clear and concise than your book. Your book goes through a bunch of different theorems, like the rational roots theorem, this and that and the other, that are helpful in narrowing down zeros, but we just don't use them very often. So just trying to give you what works the most. That's the resource for you that's available. Okay? Questions? Hi. Today, we have our last 3 methods. So we have sums and differences. You know what sum means in math, right? Okay, those are 2 wrong answers. Sum means add.
difference means subtract, right? And then you know what a square is, correct? And a cube. So we're adding and subtracting squares and cubes here.
Where is a two-dimensional figure well?
The key here is to be able to recognize. You better recognize if it's a sum and difference of the squares. So something like this. Is it a difference? It is. No, it's two squares. Squared?
Yeah. Yeah. Yeah.
Yeah, it is. What is it? It's the difference of two squared items. So to recognize that, we'll just an algorithm, and you can throw in the factors when you split. X minus 2, x plus 2. So these are formulas that help you do things a little faster. Do you have to have that? No, you don't. Okay. I can factor this just as easily with our old quadratic methods. And same thing, right? Just 0 x's. Okay, I can still factor this using quadratic methods. What multiplies you -4 and adds up to 0. -2 and +2, right? So you don't have to use this algorithm, but you can. It makes things faster.
It's just something that you would just say, how much has to be given exactly comparable to yours?
Exact what?
Like comparable.
I don't remember.
So like, if we convert this to stuff, use it like
So you use this if you want to, unless I tell you something. How about something a little bit more information in it. Yeah, so we have 6x squared, right?
minus 9.
So how do we factor it?
3 squared.
No, it'd be 6.
6x minus and
Square. No.
an algorithm, something squared and something squared. So it's minus and plus. Same thing we did up here. Just apply to something with more information.
So how come the negative is in with the number?
Here.
Everybody grouped on that.
Because if I put the negative in here, what's -9 squared? Positive, and that changes the product. Right? You need to leave it outside of parentheses. So your goal there, make it a squared, make it a squared if you can. The difference of 2 squares. Right? What else?
So, if we were to factor it out, like we were to let it would have an x in mind.
This one would have an xy in it. 0 xy. If you wanted to write this, it would be 36 x squared plus 0 xy's minus. That's how you would rewrite it. This is an awful mess. I suggest you use differences squares. Alright. So what about something like this? That's the sum of two squares, right? Can you think of a way to factor it?
It's a square. X over 4. X over 4. X over 4 squared.
No, x squared plus 4 squared. Do not say that is the same thing. Algebra atrocity, bad juju right there. Bad juju.
But it gets win.
Then you have a just x.
Okay, let's x plus 4 squared is x plus 4 times x plus 4, right?
Yeah.
Oh,
Foil.
Oh. I see.
Outsides and insides.
Yeah.
Make 8x.
Yeah.
Now I see where.
Alright, well then.
Good thought. Is this factorable? No, it's not. So different sum of two squares. Easy answer. No, that would make the difference in two squares. Yeah, there's no way to get a positive here with no x's. Right? So if I rewrote it,
There's 2x squared.
is there two numbers that multiply to get 16 and add up to get 0?
No.
No. Same problem, not factorable. Okay. So this is just a recognition thing. If you see a sum of squares, not factorable. Okay.
Every time?
It says factor, and you get a sum of two squares, not factorable. That's it, we're done. It's that easy. But you have to identify it. Don't try to make it more complicated than it needs to be. I have to look this one up. See, I don't even memorize these algorithms. Wow. Yeah, that's how little we use them, first of all.
Oh, I love that you're honest about that though. Other teachers like try to lie.
Yeah, it's just like, what do they use this in, like, oh, I gave them some lie about how they use it all the time.
Dude, you would confuse the heck out of the cashier.
One day I was ordering at Wendy's and I decided to annotate the menu.
Yeah. that would be
Miss
like
Teeter
straight
has like
cheater right
ruined
there.
everything for me. Like I can't even watch movies without being like.
Case in point, the formulas aren't even
Oh my God.
There's light bulbs in the table. What is the significance of that? There's a light bulb every between the whole of the
Ah, there they are. Guess where I had to go for these. Calculus. Alright. So, again, can you identify this as 2 cubics?
Yeah.
Yeah, K1 is 4. Right? I suggest 1, 2, 3, 4, 5 cubics in your brain. What's 1 cubed is 1. 2 cubed? 3 cubed. 27, 4, 5, 25, 25. I have those numbers. 6, 216, but I mean, you get above that, you wouldn't see it very often. Then you have calculus. All right. This factors out as x plus 4 times, what has to go here now? X squared, right? Because it has to be x cubed. X to be minus 4x.
Yeah, wait.
What? Yeah, like.
Plus,
What do you need the, what do you need?
Square.
What you found out?
16. It's an algorithm. So, if you multiply these out, you will end up back at this spot. This negative 4x cancels some things out that will go in the middle.
Oh, this is.
So 16 times 4 is 64, right? X times x squared is x cubed. Everything else cancels out because of the way this is structured.
So what's the question to get that? Like, I'm thinking
You get 16.
I don't know. It's gonna be different.
Because x minus 4 squared is okay, so here's, all you're doing is identifying terms and placing them in the right spot. The first term, x, here it's squared, and it goes here. Right? The second term is 4. 4 minus 4, 4 squared. So 5 x's, x squared, x.
And it will always be like.
Yeah, it's the same structure every time. 4 goes here, and it goes here, with a minus in front of it, and then this is 4 squared. See, you're just placing things in the right spot.
Can we do it
It's always the same thing every time. If it's the sum of cubes, that's the algorithm. You have to put it on your blue sheet. It's okay not to memorize. You just need to know how to put stuff in the same spot every time. Right? How about
Yeah, no.
so if you're asked to factor. Here's part of the reason to learn these higher level factoring techniques. You can factor all the really hard ones and makes the easier ones a lot easier. Right? See, I teach high school math, but I had to get a college math degree to do that. Right? So I know all the math up here I can teach down here.
3x cubed plus.
That's what we're doing. Okay, so we have
Let's get the 5 cubed.
right? So you have this term, these two terms, and you're just going to place them in the right spots.
27 cubed.
27 cubed is 27 is 3 cubed.
That's it. You're welcome.
What is here?
X.
3x.
Plus 5. And that'd be
Right.
x squared.
And then this here is the first term squared, so 3x squared. Right?
Minus.
And then you take both terms, 5 times 3x. first term goes in the first spot and both of them in the middle here. And then the second term. Okay, first spot, right? First spot, first spot. Last spot, last spot, last spot, and they both go in the middle. Yeah, you can rewrite this. 9x squared minus 15x plus 25.
Yeah, wouldn't it just be 9x?
X squared.
Well, you already squared it.
3 squared and x squared.
Oh.
3x times 3x. So just follow the algorithm, place stuff in the right spot. Gonna move on, or you done writing? So sum of two cubes. Identify it. Identify the terms. Put them in the right spot. I can.
So boil that here.
I'd like me to show you
I would
that.
like to see that.
Oh.
Let's do it. I want to understand.
I want to see that little plug. No, this is very handy.
Unless you want to check your answer.
Okay. There's no FOIL algorithm for this, but basically I say it's the same concept as for like every term here is multiplied to every term here. Right, so I'm going to take 3x and get every term. 3x times 9x squared.
Okay, so all three of these
3x times negative 15.
yeah, they will work. That's just to double check your word.
3x times 25. Right? I'm not going to ask you this on the test, it's purely extra. Then I'm going to take this into every term. A lot of work, right? 5 times 9x squared. 5 times negative 15. And
45 is cancel out, 75 is cancel out.
negative 45, 45, 75x, 75x, what do you end up with?
And you're here. Wait, where is it? Wait. The negative over 8. Third is the negative all of it.
Negative 45x squared and 45x squared. Yeah. There you got it. So that's both directions. Good question. Okay, difference of two cubes. Right? So this is going to be something like x cubed minus written notes.
You put them on the.
You could. What's your YouTube thing again? I get it. It's just another 10 minutes. Correct?
Yes, sir.
Okay, so what's the algorithm? Good, I'm looking it up. That's okay. Put it on your blue sheets.
Isn't it the same?
All right, it's very similar.
Except
The
it's
other one,
minus
you're
plus
just switching positive and negative signs.
Yep.
That's it. And so this is a minus. There's a minus in here. Of x minus 3.
Wait,
Minus 2.
Oh, dang it.
So you made your heart skip.
Yeah.
Hard to deal with stuff like
I
that.
got it right the first time and I was getting my heart yelling. Like, when you work it out.
I'm okay with that. So x minus minus 2, it matches, right?
Yeah.
And then we have x squared plus 2x plus 4. You're looking for a formula to write on your blue sheet. Here's how the book writes it.
I got you.
We put variables in each spot, and then it looks like this.
So like to sum the 2x with the minus when the difference is plus?
I got that. That's the formula.
This is how the calculus book presents this formula. Versus the example, which the only difference is the 2, right?
Yeah.
You plugged in. Right, that's all you did. Okay. That's why I don't present the formulas formally, it doesn't really matter. So again, x, I mean, same spots.
So wait, that's the algorithm?
Yeah. The placement of these numbers is no different than the sum, so you just have sign differences. Okay? Last one, the same. Okay. Are we okay with this?
Yes.
There. Okay, 2 worksheets. There's no spiraling today. So there's a factoring sum and difference worksheet. 1, 5, 11, and 13. And then there's a factoring all techniques. You have to be able to choose which one you're going to use. So last week or this week, 2, 7, 10, and 15. 1, 2, 7. So you got 9 problems. From the notes, from everything you've done in fact. All techniques. We mathematicians are very good at abbreviating and assigning letters to numbers. Yes, sum and diff. It's automatic. It's actually a great way to write less numbers. Google Classroom, we'll grade them tomorrow.
Good tomorrow, I'll be there.
Yeah, well, you don't do homework anyway.
Yeah, yeah.
I do.
Very good one.
Yeah.
I did the wrong thing.
That's not something that I will do that.
Thank you.